Okay, so we're going to start out today by, hey, 7.8, day number 1. Sarah, have a seat. Okay? Guys, thank you. Sarah, have a seat. Okay? Factor by grouping today and factoring polynomials completely. So the one thing I want to reference before I dive into the note page I gave you on the way in is on page 241 of your student journal. There are some guidelines here. Okay? Some guidelines for factoring polynomials. First thing you need to do, factor out the greatest common factor. So this kind of brings everything together that we've done this chapter, and I'm going to even bring a little more closure to it. But factor out the greatest common factor. Always look for the biggest number that will go in to each term. So in this case, 3x. When you pull 3x out of here, you get x. When you pull 3x out of here, you get 2. Okay? Then look for the difference of two perfect squares, or look for the difference of two perfect squares, or for a perfect square trinomial. We did that. We then use general factoring. Okay? And today we're going to go through factor by grouping. This kind of summarizes each type of factoring. I'm going to be more specific with you on it, so if you have a place where you can take some notes, extra notes, I'm going to tell you as you decide to factor or solve with quadratics, meaning it's x squared, or x to the third, if you're dealing with a cubic. Okay? What I want you to do is start counting up the terms. So as you approach a problem, if you count 2 terms, there are certain things you do to that problem. First, if I had, say, the 2 terms of 4x squared and 20x. Okay, first thing you should look for, hey, is this one perfect? Yep, it is. Is that one? No, it's not. So I can't use difference of 2 squares, but I can take out a greatest common factor. Always look for the greatest common factor. Question? Is 20 a perfect number? Like, does a number times itself make 20? No. So it's not perfect. Okay? So, and if you guys don't know the perfect numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, like if you can't go through those real quick in your head, math is more difficult. Just like if you guys can't multiply now, like 7 times 9, and you're like, math is more difficult for you. It takes longer for you to do it on your calculator. So those are things to practice, man. Okay? But anyway, it's not perfect, so we pull 4 and we pull x out. 4x times x equals 4x squared, and 4x times 5, you factored out a binomial, or a monomial, excuse me. So pull out, the way we thought about this is you're finding the greatest common factor. That's something you should look for every single time. Okay? That's all we could do there. That is our answer. Okay? You could also look for difference of 2 perfect squares. So let's say I had, well, let's use this, but let me change it up inside. Let's call it x squared minus 36. So I've taken out a greatest common factor. So a new problem here. I look at it, I've got 2 terms. This term is perfect, square root of it is x. This term is perfect, square root of it is 6. And there's a minus in between. So that is the difference of 2 perfect squares. That pattern is that. And then you just bring down the 4x. Okay? That would be your answer. This is difference of 2 squares. Yes? Why is one of them plus? Because if you were to multiply it out, you'd have negative 6x and positive 6x. That would cancel out the middle term. Okay, so if you're like, I can't figure out why one of them's plus, you have to go back. I want you to multiply this by itself and look at the pattern there. Or go back and look at that lesson we did the other day. Okay? Because we have that explanation on there. Okay? Yeah? No, if this is a plus right here, you can't do it. You can't use that pattern. You just couldn't factor it. It would just end right there. So what Mercedes is asking is like if you had x plus 36 or x squared plus 36, x squared. That is your answer. You can't do anything with that. Okay? It has to be minus. That's why we call it the difference of two perfect squares. It has to have a subtraction symbol. All right? You guys, that was yesterday's lesson. So we're in 7.8. That was 7.7. If you need help on that, go back to 7.7. This right here was 7.4, I believe. Go back to 7.4 if you're struggling on that. All right? Next thing, if you have three terms. And so I'm just assuming everyone knows what a term is, but just so we're clear, on this previous problem, when I say two terms, I'm talking one term, two terms. Okay, they're subtracted by addition and subtraction symbols. So if I have three terms, one of the patterns we had, let's say I have 25x squared and let's say 16, we'll put a plus there, and 40x in the middle. Okay? So if you look at it and you go, hey, front term is perfect, back term is perfect, I take the square root of that, I get 5x, and the square root of that, I get 4, and 5x and 4x is 20x, doubled is 40x. This is a perfect square trinomial. I have 5x minus 4 and 5x minus 4. Notice 5x, that's 20x, or this would not be x, it would just be 4. Okay? And you usually write that, rather than having a big, long quantity there, you just write it as 5x minus 4, quantity squared. So if you have the square root here and a square root here, and those two pieces multiplied together and doubled, is that, you have this pattern. That is a perfect square trinomial. This, once again, was yesterday's lesson. So if you need more help on that, you want to go back and review it, that is 7.7. The other method we use, if it wasn't a perfect square trinomial, was say you had, 6x squared plus 5x minus 6. Yeah, I think that'll work. Okay? Okay, we just use general factoring. Two things that multiply, they're not perfect in front or back, so two things that multiply to make a times c, negative 36, and add up to positive 5. We get how about negative 4 and positive 9. Okay? That's when we set up our parentheses. We took these two pieces, pulled them in there, and we said, look, we put our minus 4 and our plus 9 along with our x's. And then the one thing that some of us would forget sometimes is to divide by a. Make sure you do that. So divide by 6, and reduce. So 9 6 reduces to 3 halves. 4 6 reduces to 2 thirds. So you end up with x plus 3 halves and x minus 2 thirds. Yeah. Yep, then you pull that out in front. So you get 2x plus 3 and 3x minus 2. That's just that's general factoring. Some may call it the X method or diamond method, or you'll even hear Lizzie's method. Let's just think of it as general factoring. If it helps to call it the X method or diamond method or one of those other names, that's fine with me. Okay? Just so that you know, this method right here, you could use this method. Like if you're like, I don't really care to learn anything extra. I just want to know how to do all the problems with as few things as I have to memorize as possible. If that's the case, you really don't have to memorize that one. You could use this method, and you'd still come up with the same answer. It's just take longer. And you really wouldn't have to memorize this one, just knowing that b is 0 here. Okay? So you could, like if you're like, I don't want to memorize anything else. Well, don't memorize those two. But you better know this one and this one. You need these two for survival. Okay? If you're going to finish and make it through factoring, you have to have those two. Okay? All right, the final one that we're going to talk about is if there are 4 terms. Okay? If there are 4 terms, so for instance, that's the first problem, by the way, on the sheet I gave you today. It's right here. Okay? I'm going to work through it right here. But if there are 4 terms, your goal is to first thing you should always do, say, is there anything that will come out of all 4? No. Almost an x, but there's no x here, so we can't do it. Okay? So, with that, you're going to make up 2 groups. Okay? So draw some parentheses in there. Okay. So, I'm going to kind of write the steps off to the side here. Really the first step, and those of you who had me first period, I didn't make this our first step, but always look for the greatest common factor first. Okay, it doesn't mean there will be one, but look for it. Okay, maybe we should say look for, so when you're looking at it later. Okay, second step is to create 2 sets of parentheses. Create groups. And I'm going to kind of use a picture approach to show it there, but create groups. Nice, that would actually focus. There we go. All right. So I've created my groups. I created them randomly. Most of the problems you get, you'll be able to just create groups like this and it'll work out. But you may have to group this one with that one sometimes. Or that one, the second term with the 4th term. Right now I'm just going to try to create groups using the first 2 and the last 2. Okay? So once you do that, you're going to pull out a greatest common factor of each group. That means what goes into x cubed and 3x squared. Ignore the back. What goes into these 2? X. How many x's? It's always the smaller power. X squared. So x squared times what's x cubed? X. And x squared times what's 3x squared? 3. And now you focus on the back group. What goes in 2x and 6? 2. It's a positive 2, correct? Okay, so plus 2. 2 times what's 2x? And 2 times what is 6? The goal is for these to be the same groups when you're done. Notice you have made a common group. Okay, so the third step was for you to pull out a greatest common factor. I'm going to call it A. And another greatest common factor from your other group, which we will call B. And now you have the same thing in each of these sets. If it is not the same, you chose the wrong groups. If you've ever watched Indiana Jones, you have chosen unwisely. Anyone ever see that movie? That's when the dude's face melts and he like blows away. It's really sad. Okay. Actually, he was a mean guy, so it wasn't too sad. Yeah, it's kind of gross. Okay. You want to choose wisely. I promise if you choose unwisely, that won't happen to you. But you'll have to do more work. All right. So from there were a lot of cups. Okay. From there, you have the same groups. Any questions up to there? It's a long bell. Next step is to take our same group, which we are now calling its greatest common factor. So really you have 2 pieces. You have this piece and you have this piece. The greatest common factor of those 2 pieces is x plus 3. That is the thing they have in common. Okay? What is left is x squared and 2. That goes in the other set. So if you think of it this way, if you're writing it kind of in a picture format, you'd have same times A plus B. You have now factored it. Okay? We know we factored because now it's multiply in between and not addition. You should always check at the end, make sure you can't do anything to this, that, or that. Like if this was a minus 4, then you'd have difference of 2 squares and you have to factor more. But it's not, so we don't. Okay. How many have this copied down? This is your quick roadmap on factor by grouping. The more you do it, the easier it is. Okay, I want everyone to try. We just did letter A. I want you to try letter B off your note page here. Okay, hey guys, I don't think I actually named this word. This is called factor by grouping. That's why the directions say use factor by grouping, but that's the actual title for that. Factor by grouping. Okay, so we made our groups. That's why they call it that. All right, so on this one, greatest common factor come out? Anything that goes into x squared, y, x, and xy? Other than 1? No. So let's make our groups. Anything that goes into x squared and y? Besides 1? No. Anything that goes into x and xy? X. Yeah, x. So really what I get is x squared y, and here I'd have x times 1 plus y. Now this is where we do, did we choose wisely? No, right? Remember, our goal is to make the same sets. Are those the same? No. What does that mean? It means you chose the wrong groups. That means, what? I have to start over? Yeah. That means, yeah, you have to start over. That means these parentheses we put in here at the beginning didn't work, dude. That's ridiculous. So what usually works is when you can say, okay, look, these two, thank you, these two don't have anything in common. However, I could pair x with x. Let's try that. I could also pair x squared with xy, but we'll try this one. So notice a positive x and a positive x squared, so that means this y is going to go with that. We just move them around like puzzle pieces. Okay, can I take x out? Yep, that gives me x plus 1. If I take y out, what do I get? 1 plus x. Did we get the same thing? Yeah, I mean, this one's just backwards, right? But you could still, I mean, you could write it as, you could like have switched these around up here and made this xy and y, and then now you'd now have x plus 1. And so now you have the same. That means we take out that x plus 1, and we have x remaining and y remaining. Okay? All right, try number 2 and 3. If you need help, you have any questions on those ones we just did, make sure you ask. Oh yeah, 1 and 2, I'm sorry. Yeah, 1 and 2. Okay, so a lot of you grouped those. I saw a lot of a squareds plus, or a squareds times a plus 1s. And, or excuse me, a plus 3, not a plus 1. Okay? And then some of you are confused back here. Notice we have a plus 3, and we already have a plus 3, so don't change anything. Just leave that group like that. What number's sitting out here? Yeah, this is a 1. There's nothing there. It's a 1. So that means when I take my a plus 3 and make my remaining group, I have a squared plus 1. Is that difference of 2 squares? It's perfect square and perfect square. Is it difference? No, it's plus. It has to be minus for you to do anything with it. So we can't do anything. We are done there. Okay, number 2. There's not even a greatest common factor here, so I'm not even going to try those two. Which one should I put y squared with? 2y? Okay. So I go y squared and 2y. That'll be one set. Plus, then I have this set. 2x plus yx. Out of this one we get y. Out of this one we get x. It's kind of flipped around back there, right? So really we could think of this as y plus 2. That would be okay. Just move them around. So you get y plus 2 times y plus x. Or x plus y. Okay, how many got both of those? Well done. Any questions? Okay, moving on. Example number 2. I want you to factor letter A. Let's start with A. Tell your neighbor what the first thing is. Hey, what's the first thing we need to always check for every time? Greatest common factor. In this case, 3, 3x. There we go. We done? After you do that, you always have to see if you can factor any more. So can I ignore the 3x, can I factor the quadratic? Are there two things that multiply to make negative 6 and add to 2? 1 times 6? No. 2 times 3? No. So we are done. How about this one? Tell your neighbor what you got going into each. 7x squared. Always the smaller power. X squared minus 4. Are we done? Can you factor x squared minus 4 anymore? Yes. It's difference of 2 squares. So you get x plus 2 and x minus 2. And then you bring down the 7x squared. You have now factored completely. You got to apply them all together. That makes it a little tougher. You got to remind me during that class. We tried to do it. Okay, example 3. Give it a go. Hey, what's the first thing I need to do to solve? Subtract 10x. We need to get it set equal to 0. So if you didn't remember that, make a note to yourself. Now what? Greatest common factor is x. Oh, it's 2x. Ooh, man. Can we factor any more? Cover up that. Yep, negative 5 and 4 is 5 and negative 1. Yeah, so this becomes x minus 5 and x plus 5 and x minus 1. Thank you. Do we have to divide by a this time? No, it's 1. It won't change it, right? So we just bring the 2x down. And so now you have 3 things that equal 0. If 2x equals 0, what's x have to be? 0. If x plus 5 equals 0, what's x have to be? What plus 5 makes 0? Negative 5. And if x minus 1 equals 0, what minus 1 equals 0? 1. Yep, so x equals the set 0, negative 5, and 1. All right. Hey, we're done with instruction for today. We will complete the other side of this page as part of our lesson tomorrow. Okay? Just kind of a quick review plus a amazing story problem. I want you to take a look at page 242 of your student journal. 242. Your assignment today is page 242 and 243. Do your bestest.